what we have here is it's the same set score either side. Okay, and what happens is that is shocking. What happens is it's the same set. There's minus said one here, and there's plus said one here. And what's in between those two is this region here, which is going to be 84.84. What's it? 0.8438. Is that right? Now, I have an idea for this. 0.8438. Here's my idea. I'm going to half it. I'm just going to half this number. 0.4219. Is that okay, you guys? Now, here's what I'm thinking. So I half that number into two separate parts, right? So I'm going to half that number into 0.4219 here, yeah? Does that make sense? And then if I was to shade in the whole yellow area like this, what would the left side turn into if I included that part there? Huh? Would you all agree it's 0.5 then? Because it's 50% off the 50% of the actual distribution. Add both results together, and what do I get? 0.9219, and that's everybody below Z1. So if I go to my table and I look for that on page 33 or something, is it? Something along those lines. Here we go. Well, I'm looking for 0.9219, yeah? I think it's very close to... What's it? 0.9219. It's closer to... It's not... There's 1.41 and 1.42. Which one do you think we should choose? 1.42. Okay. And I just say said one is 1.42. Okay. So now this time it's giving me the probability of x is bigger than 294. This time I want the probability of z is bigger than something. So here's what we're going to do. We're going to get a z score. X minus mu all over sigma. Okay. Z is 294. Take away 300. Divide by 25. Can I tell me what that is? So what we have is minus 6 over 25. Okay, and what we get is minus 0.24. Is that right? Minus 0.24. So Z is bigger than minus 0.24. Is that right? And if I was to draw my graph, what I'm looking at is what's bigger than minus 0.24. Would you all agree I'm looking at this blue region here? Now, what do we have next? .24, yeah. Then what? Do you see the way it's the same? It's the same size of region, doesn't it? Being bigger than minus 0.24 is the same thing as being smaller than 0.24. Okay. So what I'm going to look for is on my chart, I'm looking for a set score of minus 0.24. So go all the way up. Everybody see 0.24 is here. So what does that give the answer as? 0.5948. 0.5948. Okay. We're bigger than average, aren't we? How do we know we're bigger than the average? Bigger than 300, yeah? So your set score is going to be 312, take away 300 divided by 25. Who got 0.48 for that? Happy enough. And then throw it in, and you go, well, look, 0.48 is bigger than the average, so it's going to be to the right of the center. And we want to be smaller than that, don't we? So it's going to be all this region in here. All the regions smaller than the set score of 0.48. Go to your diagram. go to 0.4, and then I'm looking all the way across till I get to 0.48. Who got 0.6844? Yeah? Okay. Set score for 52. We're going to get set scores for both of these, okay? So it's going to be x take away mu all over sigma. So it's 52 take 50 over 8. Who got 0.25? So this is now probability of 0.25 being less than z, and then z being less than 55 take away 50 over 8. What's that then? Is it 0.625? Is that right? 0.625. Now, doing 0.625 is going to be tricky because it's like halfway in between, isn't it? So I wonder, do we take, yeah, I'm going to look at that now. So was it question 24, yeah? Okay, I'll be interested to see this now. So they would agree that what we essentially have is we have two scores that are above the average. Agreed? So one of the scores is 0.25, yeah? And the other score is 0.625. I'm looking for the difference in size between the two of them. Does that make sense? So the first thing I'm going to do is I'm going to find out how much is below 0.25. So what is this yellow region? Okay, go to my book here. 0.25. Who got 0.5987? Okay, so 0.5987. Now what I'm going to do next is 0.5987. Then I'm going to get the area of the bigger one, which I'll call the green area now. See that area? That is everything underneath 0.625. Now I'm interested to see what they did with this. So there's 0.62 and there's 0.63. And what they did was they rounded up, or did they? Sorry, I got mixed up there. 0.625, yeah? So I'm looking for 0.63. Yeah, they used that one. They rounded up. So they used 0.7357, yeah? So 0.7357. Take them away from each other, what do we get? So what you get? 0.137. Anybody get that? Okay. 24 part 2 for anybody interested, okay? So I'm going to get a Z score of 48, take away 50, all divided by 8. It's going to be minus 2 over 4, which is minus a quarter. Okay. Next thing, I'm going to get another Z score for 54. It's going to be 54, take 50, all over 8, which is a Z score of 0.5. I draw my normal distribution. Oh, draw my normal distribution like so. Minus 0.25 is below average, so it's to the left of the middle. 0.5 is above average, so it's to the right. Okay. Now, this one's tricky, okay? So ultimately, I'm looking for the result that's in the middle. Is everybody happy with that? So here's the way I'm going to deconstruct this for myself now. The one value I have easy access to is I have really easy access to this green region here, don't I? Now, that green region is too big, would you agree? I'm looking for the shaded in black region, yeah? So I'm going to get that green region first. That's my first job. I'm looking for a Z score smaller than 0.5. So I go in here and I go Z score smaller than 0.5. That one there. Everybody happy with 0.6915? For your examiner, you might want to tell them what you're doing. So you might say, look, I'm currently doing a Z score less than or equal to 0.5. I got 0.6915, wasn't it? Okay. Now that I'm done with that, I'd really love to know out of that green region that I just had a second ago, it'd be really great if I could figure out what this part is. See that part there I'm just shading in here? If I could take away that part, then also I'd be left as the region I'm looking for. Would you agree with that? So here's what I'm thinking. I'm thinking a z-score below 0.25 is the same. So a z-score below 0.25 minus 0.25 is the same thing as a z-score bigger than 0.25. So I'm looking for is the probability of z being bigger than 0.25. Okay? So what I'm going to do is I'm going to get this red region here and take it away from 1. So it's actually 1 take away the probability that z is actually smaller than 0.25. Go to my calculator, find out what 0.25, sorry, go to my tables, find out what 0.25 is. 0.5987, yeah? So 1 take away 0.5987. 0.4013. Cool with that? All right, 0.4013. Now what I'm going to do with that is I know that this black region here is 0.4013. I'm going to take it away from this. Sorry, 0.4013. What you get me take them away from each other? 2902. Is that right with you guys? 26 part 1. We're going to do a z-score of x, take away your average divided by your standard deviation. We're going to do 190 take away 200 divided by 20. That gives me a z-score of 0.5. So it's probability of 0.5 being smaller than z. And then I'm going to do 210 here. Minus 0.5 and plus 0.5. Okay, I believe that makes things a bit easier. It's symmetrical then, isn't it? What does symmetrical mean by that? It means that minus 0.5 and plus 0.5. We're looking for this in-between region, yeah? But see this blue region at the end? It's the same size as the blue region at the front. They're going to be the same size as each other. So if I find one of them, I can just double the answer and take it away from 1. So here's what I'm thinking. I'm thinking is I get the size of this full yellow region. Everybody see that full yellow region? That's everything below a score of 0.5. Into the calculator, sorry, into the tables. Everybody happy with 0.6915? Okay, so 0.6915. And then I'm going to do 1 take away 0.6915. What is that? 0.233085. Yeah. Now that gives me the size of the blue region, which I now need to double. So I'm going to double it to get the 2 blue regions. So double my answer, and I get 0.6170. That's the size of the 2 blue regions combined. Take that answer away from 1. What do we get? 3830. Who got 3830? Okay, less than 103. So if you go to your tables, I think what it specifies at the top here is that this is what's it, less than or equal, all right? So we're looking for a z-score of, so we're going to get 103 take away 101 by 5, is it? You got 0.4 for the Z score. So this question becomes, here's where you should be writing this formally. It becomes the same as Z being less than 0.4. And we already know that because it's directly in your tables. So Z being smaller than 0.4 is what? 0.655. Is that all right? Now the next one, which is a bit trickier, requires a Z score of 98. So 98, take 101 divided by 5. Who got minus 0.6? Anybody else got minus 0.6? What's that? That's just me. What? All right, great. Happy days. Now, it changes into the probability of Z being bigger than minus 0.6. Is that all right? And this is the sort of one I need a diagram for. Me and my small brain, yeah? Now, does everybody see that I'm after the red region? After the red region, yeah? And it's symmetrical, so what am I going to draw underneath here? It's the same as what? It's the same as it's the same as being smaller than 0.6. So if you can do that in your head, here's what you should write. It's the same as Z being smaller than 0.6. That's what you should write. And then the examiner knows what you did. And he goes, okay, he went for minus 0.6. Who got 0.72? Yeah, easy money. So the answer is 0.7257. The last one has a bit of courage to it. So what's 95 take away 101 divided by 5? Minus 1.2. Next one, 100 take away 101 all over 5. Yeah, double negative, which is unusual. I actually have a quick way of doing this as well. You'd be happy to know. Ready for this? Okay. So for me, this looks like minus 1.2 is over here. Minus 0.2 is very close to the center. Everybody see that? I think this region here is exactly the same size as what? I think it's exactly the same size as 0.2 going to 1.2. Sorry, 0.2 going to 1.2, yeah? So if I was to redo this, the language, here's how I do the language, ready? I'd say equals this equals probability of minus 1.2 less than or equal to Z less than or equal to minus 0.2. And then I'd say that in turn equals probability of 0.2 less than or equal to Z less than or equal to 1.2. Do you see how I wrote those 3 lines? TF. See those 3 lines here? I'm just explaining to the examiner what I'm actually doing. Okay. Now that I've gotten that far, what I'm doing is this part here. Now, I think we did this earlier. What I'm going to do first and foremost is I'm going to get this. I'm looking for this blue region here. Everybody cool with that? So I'm just going to shade it in. I'm looking for this. See the red lines? That's what I'm looking for. Okay. Now I'm going to get all the values that are underneath 1.2. How do I find that out? All the values less than 1.2. So all the values less than 1.2. Who got that? 0.8849. Okay. And then from 0.8849, what are we going to take away? Does everybody see? It's going to be the black region again, no doubt. Everybody see this actual blue region? Blue and pink. I'm going to get this region and I'm going to take it away from it. So how do I get the area of this region? Less than 0.2. Okay, and here you go. 0.5793. Okay. And what you get when you did both of them? What you reckon? I'll look at myself. So 3056. Yeah. All right.